Here's problem 32. Two long parallel wires carry unequal currents in the same direction. The ratio of the currents is 3 to 1. The magnitude of the magnetic field at a point in the plane of the wires and 10 centimeters from each wire is 4 microtesla. What is the larger of the two currents? Well, if we're in the same plane as the two wires, then the distance between these wires must be the 20 centimeters, with this point being exactly in between. So let's think of it, one wire, let's call it I1, carrying a current out of the page, and is 10 centimeters away from the origin, which is the point that we wish to consider. Let's call that P. And then the other wire, which is going to be I2, I1 is equal to I, I2 is going to equal 3I, and that also has a current coming out of the page towards U, located at Y equal to 10 centimeters. Alright, if we consider by the right-hand rule that there is magnetic field going around each of these wires, for I2, that magnetic field is going to be going in the positive x direction, B2 like this. For I1, going by the right-hand rule, it's actually going to be going in the negative x direction. And since it's a smaller current, it's going to be a smaller field for I1. So these two fields, B1 and B2, are going to be in opposite directions, and that one is going to subtract from the other. Sounds good. Alright, so B1 is going to be equal to mu naught I over 2 pi R1, and that is going to be 4 pi times 10 to the minus 7 for mu naught times I over 2 pi, and we are 10 centimeters, 10 times 10 to the minus 2 meters away. The 4 pi divided by 2 pi will leave us with a 2, and 10 times 10 to the minus 2, 10 to the minus 7 divided by 10 to the minus 2 is 10 to the minus 5 divided by 10. This is going to be equal to 2I times 10 to the minus 6 Tesla, whatever that is. For magnetic field B2, that's going to be equal to mu naught I2, which is actually 3I, over 2 pi R2. So this is going to be 4 pi times 10 to the minus 7 times 3I for I2 over 2 pi, and it also is 10 times 10 to the minus 2 meters away. So the 4 pi divided by 2 pi will give us 2, and then the 10 to the minus 7 divided by 10 to the minus 2 will be 10 to the minus 5 divided by 10 again is 10 to the minus 6. So this is going to be equal to 6I times 10 to the minus 6 Tesla. We are told that the magnetic field that actually exists at that point is 4 microtesla, and it should be equal to B2 minus B1. So our magnetic field is B2 minus B1 because they're in opposite directions, and this is going to be equal to 6I minus 2I times 10 to the minus 6, and we're told that that is equal to 4 microtesla, so that's 4 times 10 to the minus 6 Tesla. 10 to the minus 6 cancels on both sides, and we're left with 4I equal to 4, or I is equal to 1 amp. That's nice to know. That is the smaller of our two currents. I2 is the larger of our two currents, and that is equal to 3I by definition. So that is 3 times 1, or 3 amps. So the larger of our two currents in this problem is I2, which is 3 amps.